Most of us grew up thinking of arithmetic as just this rigid, kind of boring set of rules for crunching numbers. But today, we are going to completely shift that perspective. We're going to see how math isn't just a series of arbitrary calculations, but a beautiful, expressive language with its own vocabulary, its own punctuation, and its own grammar. We are going to learn how to read mathematical expressions fluently, exactly like you'd read a sentence in a great book.
To really get math, we actually need to look at English for a second. Take a simple sentence. Shalini sat next to a friend with toys. Pretty obvious, right? This implies the friend has the toys. But if we just drop a single comma in there, Shalini sat next to a friend with toys, notice how the meaning completely flips. Suddenly, it's Shalini who has the toys. Just like spoken language desperately needs punctuation to avoid confusion, mathematics needs its own set of symbols and structures so that everyone reading an expression gets the exact same meaning.
So here is our roadmap for today. We will cover the language of math, comparing expressions made easy, brackets as math's punctuation marks, understanding mathematical terms, and lastly, the grammar of numbers.
Let's start with Section 1, the language of math, decoding expressions. Think about how words combine to form sentences in everyday conversations. Well, in mathematics, the fundamental building block is the arithmetic expression. An arithmetic expression is really just a phrase that tells a story, and that story results in a specific value. When you read 13 plus 2, you instantly know that value is 15. Or say a student, let's call her Malika, spends 25 rupees a day for lunch from Monday to Friday. We can just write the expression 5 times 25. It's this incredibly precise, compact way to express a real-world situation.
Moving on to Section 2, comparing expressions made easy.
Now, this is where it gets really cool. We can actually read the relationship between expressions without doing any brute force calculations. Imagine a real-world scenario where two kids, Khaja and Joy, are comparing their massive marble collections. Let's look at the sheer logic of their situation instead of, immediately reaching for a calculator.
Okay, so Raja starts with 1023 marbles and gets 125 more today. Joy starts with 1022 marbles and gets 128 more today. So who has more? Well, look at those starting numbers. Raja begins with exactly one more marble than Joy, right? But consider what they gains today. Joy gains 128, which is 3 more than Raja's 125. So since Joy was only behind by one single marble, but gained 3 extra today, just by reading the context, we know for sure Joy has more. We didn't even have to do the heavy addition. We can confidently say Raja's expression is less than Joy's expression.
All right, Section 3, math's punctuation marks using brackets.
We have officially reached the punctuation of our math language, which is absolutely crucial because it resolves total chaos. Take a look at this mathematical phrase, 30 plus 5 times 4. Without punctuation, it's super confusing. I mean, do we add 30 and 5 first to get 35 and then multiply by 4 to get 140? Or do we multiply 5 and 4 first to get 20 and then add 30 to get 50? Without a clear rule or symbol, we are literally just guessing, exactly like that sentence about Shalini and the toys.
Enter brackets. Brackets are math's punctuation marks. They tell us exactly what to read first. Consider this real-world example. Irfan buys a biscuit packet for 15 rupees and some dal for 56 rupees. He hands the shopkeeper a 100-rupee note. If we write the expression for his change as 100 minus 15 plus 56 without brackets, we might accidentally subtract 15 from 100 to get 85 and then add 56 to get 141. And obviously, it is absurd that he gets more money back than he paid. Instead, we absolutely must use brackets to group the cost of the items first. 100 minus, open bracket, 15 plus 56, close bracket. We evaluate the brackets first to get 71, and then subtract that from 100, which leaves us with the correct change of 29 rupees. Brackets bring order to the chaos.
Which brings us to Section 4, mathematical terms, breaking it down.
Let's see how this all builds by breaking our math sentences down into smaller, bite-sized syllables. See, when we don't have brackets to hold our hands, we read the order of operations by identifying terms. You can think of terms as the individual chunks or syllables of an expression, and they are specifically separated by addition signs.
And here is where it gets interesting, because this brilliantly illustrates how we deal with subtraction. Actually, subtraction is really just the addition of negative numbers in disguise. For instance, the expression 83 minus 14 is rewritten as 83 plus negative 14.
By doing this, we turn complex, multi-operation phrases into separated syllables. Our terms for that expression are simply 83 and -14. Identifying terms is super helpful because it allows us to evaluate any multiplication and division inside those trunks first, before finally adding the whole shebang together at the end.
And finally, Section 5, the grammar of numbers, essential rules.
So let's explore the grammar rules that allow us to rearrange our math sentences without changing their core meaning. In math, we have 3 incredibly flexible grammar rules that give us the power to manipulate expressions to make them way easier to solve: the commutative, associative, and distributive properties. Now, I know these might sound like heavy academic terms, but you actually use the logic behind them every single day.
Let's start with the commutative property. This rule simply means that swapping the order of terms being added doesn't change the outcome whatsoever. Think of it like getting ready to go outside. If you put your hat on first and then your shoes, you look exactly the same as if you had put your shoes on first and then your hat. The order just doesn't matter. In math, 419 plus 423 is exactly the same as 423 plus 419.
Next up is the associative property, which basically says how you group the terms doesn't matter. Imagine you're adding up a massive list of numbers, and after 5 minutes of sweating over it, you get a total of 11,749. But then, oh no, you realize you forgot a number in the middle of the list. Because of the associative property, you don't have to start all over again. You can just tack that forgotten number onto your final total. Grouping the numbers differently still yields the exact same sum. And honestly, the distributive property is just a fantastic shortcut. It shows that a multiple of a sum is the exact same thing as the sum of multiples. Let's look at an expression: 10 times 98 plus 3 times 98. Instead of calculating those 2 large multiplication problems separately, which sounds exhausting, we can just recognize that we have 10 groups of 98 and 3 more groups of 98. Well, that's just 13 groups of 98 total. We can rewrite it as 10 plus 3 in brackets times 98. It takes intimidating math and turns it into a much simpler calculation.
So what does this all mean? The big takeaway here is that arithmetic is absolutely not about blind calculation. It's about fluent reading, logically comparing things, and cleverly rearranging terms to work for you. When you truly understand terms, brackets, and these core properties, you transform from just a human calculator into an expression engineer. You control the numbers. They don't control you.
I am going to leave you with one final puzzle to test out your new grammar skills. Using the numbers 0 through 9 exactly once in any order and applying the operations and brackets we talked about today, can you write your own math sentence that equals exactly 100? Try swapping terms, grouping them differently, and just playing around with the language of math. It's like a giant puzzle waiting to be solved. Give it a shot and keep exploring.